Well, thank you so much for joining us. Thank you, everyone, for joining us today. And this is our first seminar of the 2025 to 2026 season. And to kick us off, I'm so excited to introduce Dr. Jamie Zeitzer. Dr. Zeitzer is joining us from Stanford University, where he is a full professor in psychiatry and behavioral sciences and co-director of the Center for Sleep and Circadian Sciences. Dr. Zeitzer is also the chair of the Research and Development Scientific Review Subcommittee for the VA Palo Alto Healthcare System. And before Stanford, Dr. Zeitzer received his PhD in neurobiology from Harvard University, and he completed his postdoctoral training at UCLA and Stanford. And across his career of over 25 years, Dr. Zeitzer's work has been fundamental to our current understanding of how brains across species respond to light exposure and how sleep and circadian rhythms are regulated by light hormones, brain networks, and neuropeptides. According to Google Scholar, he's published more than 150 peer-reviewed manuscripts, and his research has been cited over 13,000 times, earning him an H-index of 52. Apart from his innovative original research, Dr. Zeitzer is also active in sharing his expertise through public outreach, as his insights have been featured in outlets such as Time Magazine, Inc.com, and Stanford Medicine CNIX podcast miniseries, among others. Most recently, Dr. Zeitzer's projects have focused on optimizing lighting for human sleep and circadian health, along with the role of wearables in sleep. Along these lines, the work he's presenting today is on novel techniques in light therapy and how light and behavioral interventions can be combined to support sleep in adolescents across different geographical and cultural contexts. The title of Dr. Zeitzer's talk is Reclaiming Teen Sleep, Innovative Biocultural Strategies from the US and Taiwan, and we're grateful to have him here to share his work with us. And with that, I will turn it over to Dr. Zeitzer.
Thanks so much, Gina. Thank you so much for the invitation. It's really a pleasure to be here. I wish I was there in person, but you've got an amazing group there, and I'm excited to share some of our research data with you guys. So let me see. Okay. All right. So the perfect storm, obviously, from your guys, not me. But typical adolescent sleep, as you all know, has this problem where you've got a later bedtime due to both circadian homeostatic and social signals with this fixed weekday wake time leading to short sleep opportunity and chronic sleep deprivation. So this is something that is really, it's kind of ubiquitous. We see this around the world. And the question is what to do about it. So one thing that you could think about doing is changing where the circadian system is positioned relative to the sleep. And so basically, when you take a look at children and adolescents, there isn't a problem in phase angle. And this is something that we didn't understand until about 5-6 years ago. But that there's no problem in the phase angle. It's the phase, and exactly how phase gets there is not totally clear. But basically, when you take a look at phase, if so a kid's going to sleep at 1, melatonin onset around 11, someone's going to sleep at 8, around 6, there's no change in phase angle. So the relative position of the circadian clock relative to sleep appears to be normal in adolescence, despite the fact that they're going to sleep so much later. So the problem is that this position of the circadian clock is also known as the forbidden zone. So this time right before you normally fall asleep, it is very difficult to fall asleep during, because this is the time where the circadian system is signaling at its strongest amount to keep you awake. So this is, when you travel and you're going eastward, why it's so difficult to sleep when you're trying to go to sleep at your normal bedtime is because the circadian system is telling you to be awake at this point. So telling a kid just to go to sleep earlier doesn't really work. You can try it, and there have been various kinds of behavioral strategies trying to get children to go to, or adolescents to go to sleep earlier than their normal bedtime, and it is exceedingly difficult to do so because the circadian system is really trying very hard to keep you awake. So, question is, what can you do? Could we move this circadian system earlier to enable an earlier bedtime? So basically take this position of the circadian clock and kind of jet lag them permanently an hour to enable an earlier sleep. And so when we take a look at data from Charmaine Eastman and Stephanie Crowley, this is the PRC that they developed. basically what you see is that you get peak advances in the circadian system in the hour just before normal wake time. And this is where you would want to apply light. So this is a light phase response curve. So you'd want to apply light in the hour before normal wake time, because this would then shift the circadian system to an earlier time, enabling earlier sleep. So that's the theory. You give light early in the morning, right around normal wake time. Kids will be able to go to sleep earlier because you're moving the entire circadian system earlier. The problem is that this can't just be a one-off. You have to do this every day. If you don't do this every day, the circadian system is going to snap back to its preferred phase. It's also problematic because if you wake up a teen early, you're kind of defeating the entire purpose of this because you wake them up early and then they're going to get even less sleep. So that's problematic. And anyone who's had adolescence knows that it's very difficult to wake up teens early anyway, even if it's on time. So this has been kind of the general problem in the clinical sleep field is how do you actually do this? And so one possibility is, well, you can administer light during sleep that doesn't disturb sleep, which is kind of a weird concept, but it's one that we've been exploring for a number of years now. And so basically the idea is that if you give light during sleep, during that last hour of sleep, then you're going to evoke advances in the circadian clock, which is going to then move the circadian system earlier, enabling kind of an earlier bedtime. And so the way that we've approached this, because we figure, well, if you're giving continuous light, and Dan Kripke's lab has done this for there's several experiments. Michael Grandner was involved in some of these, and Ando was involved in some of these. If you give continuous bright light to someone, it may A, wake them up, and B, even if it doesn't wake them up, when they have a spontaneous awakening and you've got this big bright light stimulus on, it's kind of annoying and will wake you up anyway. And so continuous bright light exposure during sleep doesn't work great. And I should mention that light can pass through the eyelids just fine. Around 10% of the light gets through closed eyelids, depending on the exact wavelength. So shorter wavelengths don't pass as well. Around 4% of blue light gets through, and about 12 to 15% of red light gets through. But on average, around 10% of light gets through the eyelids. So you can do this. You can get light into the brain during sleep. But again, if you give continuous light, it tends to be a bit problematic. So we decided to go after something which was weird in the circadian system, which is that this is an old piece of data from David Burson, who is, I think he's still at Brown. And basically, what you see is that if you give an iPRGCs, and these are the cells that connect the retina to the SCN, to the circadian clock. If you give an iPRGC a stimulus, and this is an example of a 30-second light stimulus, and then you turn the stimulus off, the cells continue to fire for several minutes. In neurobiology, that's weird. Usually, when you have a stimulus, when the stimulus ends, the firing stops. If these were cells that you could actually form conscious visual perception, then the problem would be is that you turn the light off and you would still think you're still seeing a light stimulus. So it kind of makes sense for these cells to do this because basically it allows them to integrate. So if you have a discontinuous light form, these cells continuously fire. So basically if you blink or close your eyes, or if the clouds come in front of your eyes, or if you're under a tree for a few seconds, basically these cells continuously fire as if there was still light. So even if there's discontinuity, these cells still fire. So this is a weird thing that these cells fire despite the fact that there is no light happening. So you show light, you turn the light off, they continue to fire. Kind of weird. So can we use this to our advantage? Well, there was a study back in 1998 with Tony Van Poel, and he was out at Stanford with Craig Heller doing a sabbatical. And apparently, as this story, at least I'm told this story, I don't know how true it is because it doesn't sound particularly true, but the first part sounds true, which is that they did an experiment, didn't quite work out, and they had extra mice. And then the story goes that they decided to do this really weird experiment, which is basically is that to give single flashes of light to a mouse for an hour. So every minute you give one flash of light, and you do this for an hour. So if you just give one flash of light, and that's these closed circles, you really don't get much of an effect. And Joe Takahashi, back in 1994, had already shown this, that single flashes of light were not particularly effective at changing the circadian time of a rodent. But if you do this for once an hour, then you kind of see here a nice looking phase response curve. with a fairly robust shift. So this is giving a flash of light 1 minute for an hour. And so these are 3 millisecond flashes. So this is giving 3 millisecond flashes. That's 0.18 seconds distributed over an hour. So it's less than 1/5 of a second, and you're getting 2-hour phase delays in a mouse. That you don't see phase advances is not that weird. Many mice don't actually have a phase advance to their curve, just phase delays. Um, but this was kind of weird. And again, they showed this in 98. Craig then basically bugged me about this for a number of years. I kept on telling it's not possible in humans, but we decided to try it anyway. He kind of wore me down about this. And then we tried it in humans, and what we saw is that actually, when we do the same experiment, so one flash per minute for 60 minutes, you actually get a decent phase change in humans, right? You get around a 40-minute phase shift in humans when you do this kind of stimulation. So we showed that, oh, well, actually, humans can respond to flashes of light. Isn't that weird? Um, we then said, okay, well, can we do this during sleep? And when we do this during sleep, the answer is yes, is that when you give these flashes of light, you can actually phase change humans during sleep. When you then take a look at the sleep, we couldn't find any gross disruptions to sleep. It's not saying there's no disruption to sleep, but it is not at least at the level that we could see in the 20 or so participants that we had. We couldn't see any differences in classical sleep staging, number of transitions, or in power spectrum. So there didn't seem to be anything grossly changing sleep. When we asked the people about sleep, the one person who said their sleep was disrupted was actually in the control condition, just getting light. So that was always fun. So we decided to pursue this. So we took a look and said, well, can we get more out of it? Can we get more than just a 40-minute phase change with the light? And so Ray Najjar, who's now faculty at Duke, and you may have met him if you were at um, in Singapore this last week, Ray did a study where he looked at different frequencies of the light. So instead of giving it once per minute, if you give it closer to once every 10 seconds, you can get up to 2 to 3 hour phase changes. And I should mention, using the same intensity of light, which is 1800 lux, we get around 50 minutes of phase change when we give it continuously. And so you're seeing a very variable but considerably more robust changes in response to the light flashes. I'd be happy to talk about this later, but this is a really weird phenomenon. We see always lots of variability in response to light flashes. We don't understand why, but this is also observed in mice, in rats, in hamsters, and oddly enough, in Drosophila. So these are the species that have been looked at in terms of responses to sequences of light flashes, and all of them have much more variable responses to light flashes, despite the fact that in Drosophila, the mechanism that they use to change light information into a biochemical signal is quite different from what mammals use. So we can change it with frequency. Manuel Spitzschon, who's now at the Technical University in Munich, he looked at intensity changes, and we actually don't see much change with intensity. Daniel Joyce, who's at Southern Queensland, did this experiment with us when we looked at how long the stimulus. So if you give it, we had given it for an hour, and so if you give it for 3.5 hours, or even down to just a few minutes, how much change you get. And again, most of this seems to be happening very quickly. I'm going through these quickly because I want to get to the good stuff about adolescence. Also showed that there's a high sensitivity to flash intensity. Renska Locke, who is a current postdoc in my lab, who is going to be taking a faculty position in Boulder. She'll be getting there in a couple of months. Also showed that when we optimize this and do this during sleep, we can get very large phase changes. So we can get up to 5 or 6 hour phase changes when we give the right sequence of flashes during sleep, which basically means is that if we give the right sequence of light flashes during sleep to someone who is, say, I don't know, in Rhode Island, basically you can do this the night before they leave for a trip for Europe, and they're basically in Europe almost before they leave the next day. So we can get these very robust changes in circadian timing when we give light flashes during sleep. We also looked here, we looked at standard scoring, and we did not see any changes in sleep. We also looked at probabilistic sleep scoring, which basically gives you how closely does the stage, and this was scored in 20-second epochs, match and wake and 1 and 2 and 3 are REM, and also it didn't change the probabilistic scoring. So again, can't find major changes in sleep uh, in response to this. So the question is that, well, we've got this light flash therapy we can do during sleep. It's more effective than continuous light. We can do it during sleep without having gross impacts to sleep. It's super convenient and it's passive because basically you can set up a light and just have it flash at the right time. So can it be used in teens? So that's our question. And so what we did was we took 72 adolescents and we put them into a clinical trial. These are all adolescents, grades 9 to 12. Basically, they said they had difficulty going to sleep earlier and they wanted to go to sleep earlier. So the main exclusions that we had is just there was no structural barriers to going to sleep earlier, like they didn't have a job or something like that that prevented them from going to sleep earlier, or they weren't living in a multi-family household where it was just too chaotic to go to sleep earlier. So there's no structural barriers to it. They weren't currently being treated and they didn't have bipolar. They didn't need to meet the criteria for DSPD. I happen not to like that criteria very much, even though I was partially responsible for writing that in the last version of the DSM. Um, but basically, they had to want to go to sleep earlier. That's the key thing, and they wanted to be able to go to sleep, and they technically could go to sleep earlier. So we took these 72 adolescents and we randomized them. Half of them got an active treatment, and the other half got sham treatment. The active treatment was a 3-hour stimulus, which was every 20 seconds, getting a 3 millisecond flash of 4,000 light, 4,000 lux light, which is it's a broad spectrum white light. It's around 2 to 600 lux at the cornea after eyelid filtration. And they got this every day for 4 weeks. And so we did a 1 week baseline, we did 4 week intervention. They got this every week. And then we had a sham intervention where it had the same parameters, except it was just 1 flash per hour, which we have not found to be effective at changing it. So basically, we told them that you're going to get light, everyone's going to get light, and it was just that the sequences are going to be different. So we thought that this was a very kind of believable sham condition. Um, and so we were measuring evening sleepiness and recording sleep through diary collection. Um, and these are some of the parameters that we got. So basically, most of them were going to sleep after midnight. They're actually getting a decent amount of sleep, almost 7.5 hours, having reasonable sleep efficiency, okay sleep quality, and were sleepy in the evening. So basically, kind of a typical adolescent sample, if not actually pretty good in terms of how much sleep that they're getting. So we did all this and it was a total bust, right? We found that we could make them tired earlier. So we looked at the EMA data. Basically, the ones in the active group were getting more tired in the evening, and the ones in the sham group weren't getting any more tired. But they didn't actually change their their sleep time. So this was very disappointing. Unfortunately, this was kind of an initial foray for me into adolescence, and adolescents apparently aren't just teenage versions of rats, where if you do this to a rat, they'll go to sleep earlier. But apparently, if you do this to a teen, they decide that they're going to stay up late and just be tired. So basically, in essence, we found a very complicated way to piss teens off, which for any of you who have teens, know teens, were a teen, know that this is not a complicated thing. So what we decided to do is try this again. And so what we did is we took a group of 30 adolescents, again, same criteria for them. So what we did is, again, we did a 1 week baseline, 4 week treatment. We shortened it up to 2 hours instead of 3 hours. We had some concern that maybe 3 hours we were getting into the crossover zone. And fortunately, I had a very talented postdoc in my laboratory, Kate Kaplan, who was trained as a behavioral sleep scientist. So she developed a 4 session education and CBTI based treatment. And so basically, once a week for 4 weeks, they got this behavioral treatment that was this combination of CBTI, motivational interviewing, values based clarification. And the idea was, well, can you convince them to try to go to sleep earlier? Right. So again, we think that we are biologically enabling them to go to sleep earlier. But if they don't try to go to sleep earlier, well, then they're not going to go to sleep. And so that was kind of the purpose of this. And there were these 4 in-person sessions. Again, we did diary and EMA. Um, we have similar kinds of baseline data from them. So again, sleep onset time just after midnight or so. Again, getting around 7.5 hours of sleep with good sleep efficiency. So again, these are actually decent sleepers, but they did want to get more sleep and they wanted to go to sleep earlier. Um, and so when we did this and we take a look at the sham plus CBT, so these are all individuals who are getting a light stimulus that shouldn't be changing their circadian time, but they were getting these 4 sessions of this cognitive behavioral type therapy. And so they were actually, their sleepiness was a little lower in the evening. They got into bed around 15 minutes earlier, and their sleep onset time was 20 minutes earlier, and they actually had a 12-minute increase in sleep time. So basically, every night they were getting 12 more minutes of sleep just by using this kind of behavioral sleep intervention, which is pretty good. And the sleep quality increased a little. I don't know, not significantly, but it did increase a little. However, when you compare this to combining the CBT with the light, what you see is that there's actually much better. So first of all, evenings, they're actually, instead of being less sleepy in the evening, they're actually more sleepy in the evening, which is kind of aligned with the idea that you move the circadian system earlier. They're getting into bed almost 45 minutes earlier. Sleep onset times 50 minutes earlier. And the kicker is they're getting 43 minutes of sleep extra per night. So every night they're getting 43 more minutes of sleep. Again, there was a nominal increase in sleep quality, which not significant. But point is that they're getting more sleep every night. 45 minutes of sleep every night. So we thought, hey, that's kind of cool. I mean, that's a lot of sleep. When you look at the evolution, this is kind of the change in nightly sleep time over the 4 weeks. This is the individuals in the sham group. So you see there's a slight increase over time, and this is what you see in the active group. So again, we were kind of excited about this. However, there are limitations to this, and kind of important limitations. And so the main limitations here is that people who are sensitive to light during sleep, they wouldn't have signed up for the study. There's going to be people. My mother-in-law, we call her the human photon detector because there's a stray strand of light out there and she'll wake up. So they're not going to be helped by this. So anyone who's really sensitive to light is not going to be helped by this. People who can't go to sleep earlier, they're not going to be helped by this. It also requires one-on-one kind of behavioral intervention to motivate them to actually try to go to sleep earlier. And there's a dearth of providers who know CBTI and let alone trained in this particular kind of setup. And then importantly, does it last? So this is over 4 weeks. It's great, but maybe after, a month or two, they decide to give up. And then does it impact more than just sleep? So again, it's nice that we see this big increase in sleep, but does that then lead to improvements in things like mood and academic performance? Don't know. And then there's also this issue of having a beacon. So if you have so I should mention that we put a bridge beacon in the room. That's what was providing this light. If you have roommates or if you've got a bed partner, you got a sibling in the room, it would affect them. There is a company that makes a mask. So you could use a mask, but that would require an active choice, which I'm not a big fan of. So these are just some of the limitations to really kind of consider. So to address some of these, we actually have an ongoing study. We've got more than 250 people who have been through 4 different tranches of data collection. We've got 10 weeks in the fall and 10 weeks in the spring, so it's a full academic year. We actually changed over the intervention. So instead of having 4 in-person behavioral interventions, Lauren Asarno, who used to be at Stanford and the UCSF, now she's at USC, helped us convert Kate's behavioral intervention into a series of short videos. So these are all basically 1 to 2 minute videos that get sent to the adolescents, and then they can watch it on their phone. And this can kind of conveys the same kind of information. And so we've converted this over, and we're basically also looking at the cognitive and behavioral concomitants of this intervention. So basically, does it change things like academic performance and mood? Are they healthier and happier after the end of the year? Did they just abandon this after 1 to 2 months, or did they do it for the full year? And we are in the final year of data collection, and hopefully this summer we will have some answers as to did this work, which is exciting and a little scary after 4 years of blinded data collection. If it does, we plan to basically make all of this freely available. So all of these videos, we plan to basically set up a system so that students can just, put in their phone number and then they'll get sent these videos. And then we hope to contract with the company to make these beacons available kind of at cost. You can get them, the beacons we get, anyone can get them. It's just not easy. This is a customized beacon from a company in England that makes bespoke beacons, which I didn't know anything besides a suit could be bespoke, but apparently beacons can be as well. So that is our plan of what we are doing. So that kind of gets into that's our first study. And so basically, I think that, what we've shown is that, using these flashes of light, you have the capacity to move the system earlier, but you have to couple it with a behavioral intervention to convince them to at least try to go to sleep earlier. And so then the real question is, well, if you do that, is it lasting? And so that's really the question that we're trying to answer. Is it lasting? And then, does it matter? So moving on to the second part, which is the structural barriers component. And so this is a completely separate experiment that was done with a collaborator of mine, Yating Yang. She actually came to my lab to do a sabbatical, and she is an education professor at NCKU in Taiwan. And she came to learn about using the kind of the flashes and in adolescents, because that's the group that she works with. And then we figured out very rapidly that this was not a good idea. And the reason is that because they do have the same problem in Taiwan, which is that they don't get enough sleep. The problem is that it's a different cause, which is that they're not just going to sleep late. They're going to sleep late because they can't go to sleep earlier. So they're under a lot of stress. They don't get enough sleep. And so if you take a look at kind of the clock, all right, they're sleeping about 6 hours or so. They're getting up around 7 o'clock in the morning. They go to school from 8 a.m. until 4 p.m. Then they go to something called cram school, which is extra math, science, and English. And cram school usually doesn't let out until around 9 or 10 o'clock at night. They then go home and they've got a tremendous amount of homework. So much so that when Yating's daughter was here, she was at the local high school, which is notoriously competitive. It's extraordinarily competitive. They have a a non-zero suicide rate at this high school. So it's very, very high stress, high strung, poor kids going to this high school. And at the end of the semester, Yating's daughter was very disappointed having to go back to Taiwan because she said she fell so far behind by being at this easy American school. So they have lots of homework. So they just don't have enough time, and they're a bunch of very stressed out kids. And so the question is, could we help them? Could we help them get more sleep and to kind of be more alert and during the daytime? So again, that was the problem that we were trying to tackle there. And so what we did here is this is a semester-long study. Basically, we had a week of orientation, a week of baseline, and then a 12-week intervention that spanned actually 16 weeks. There were 4 weeks off for exams in there. And so what we did is we had 5 classes, and there were 146 students. They're all 15 to 16-year-old female students. And the 5 different groups that they had, we had one group which was a control group. They had a conventional health class and conventional lighting in their classrooms. We had an exercise group where basically we had them do 30 minutes before school started. They did outdoor exercise. We had another group that did a 12-week mindfulness class. And then we had another group that had smart lighting that I'll describe. And then a 5th group that had the mindfulness class plus the smart lighting. So the idea in the exercise group is that we get them early morning light, which would increase circadian amplitude, and same thing with light. And so this is a picture over here. This is from Megan Jewett. This is an old study. This is called a phase amplitude resetting map. It basically shows what happens to both phase and amplitude when you apply a light stimulus. And so If you are seeing dots go, so basically amplitude is how far out you are from the center, and then phase is where you are in terms of which degree here you are. And so 8 to 12. So in the morning, that's this section of the curve. And basically what you see when you're in this section of the curve is that you have both changes in the timing of the clock as well as the amplitude. So when light is going from these squares, which is initial phase, to these dark squares, so empty squares to dark squares, empty is the initial phase, dark is the final phase. If it's further out, then that's an increase in amplitude. So you get robust changes in amplitude when you see this. And you can also see over here when you're giving it in the evening time, you actually see reduction in amplitude in the early part of the night in the evening. So the idea is that if you give light during the daytime and in the morning, that you can get kind of robust changes in circadian amplitude, and maybe this will help. The idea with ACT, which is the mindfulness therapy that we use, was to reduce pre-sleep anxiety. So basically, they're very stressed. They get into bed, they finally can turn out the lights, and they are so stressed they can't fall asleep. So the question is, well, can we help them with that? So in the control intervention, so this is just to describe some of the lighting parameters. Basically in the room, again, this is standard fluorescent lighting. It varies depending on where you're sitting in the classroom. So if you're near the window, you're getting around 1100 lux. If you're away from the window, you're getting around 500 lux. On average, it's around 700 lux in the room. If you're near the window, the light is more bluish. If you're away from the window, it's a more yellowish light. So, but it's basically to say is that you've got pretty standard kind of fluorescent lighting in this classroom. It's messy. It depends on where you're sitting about how much light you're getting. Um, the exercise intervention was from 7:40 to 8:10 in the morning. During the first 3 weeks, there's a 5-minute warm up followed by 25 minutes of walking and running. We then changed this to 10 minutes of running and walking with 15 minutes of volleyball, and then changed this again to 5 minutes of warm up followed by 25 minutes of volleyball. And I'll kind of get into what exactly happened there. This is the CBTI. Basically, there was both sleep and CBTI information that was conveyed to the students. This was in kind of group sessions in school. And so there are various kinds of information that we were giving them. And the idea behind ACT, and for the psychologists in the audience, I apologize in advance, but it's basically, in a nutshell, saying, so this is acceptance and commitment therapy. It's basically saying your life sucks. So does everyone else in this room. Everyone's life here is really terrible in terms of having to deal with this stress and sleep. And actually, it kind of makes people feel better about this. So this was kind of the intervention that we used over the 12 weeks. The lighting intervention that we used was a smart LED based sensor system. And so basically between 8 and noon, we ramped up over the week. So in the first few weeks, it was 1,000 lux, then 1,250 lux, and 1,500 lux. The system had sensors spaced evenly throughout the room that acted as a feedback system to the array. So basically, we could control the lighting so that it was evenly lit across the room. So basically, the LEDs by the students near the windows were lower than the LEDs in the students in the middle of the classroom that were away from the windows, so that basically everyone was getting about the same amount of light no matter where they were sitting in the classroom. And it was enhanced from what they would be getting normally in the classroom. So instead of getting on average 700 lux, again, so they're getting up to twice as much light in the room. So this was kind of the lighting design that we used. We did a variety of evaluations as pre-post. So we did at the beginning and the end of the intervention. We looked at sleepiness, stress, depression, concentration, sleep, and this was through actigraphy. We also did academic performance, which was looking at T-scores of the midterm and the final in Chinese, English, and math. And so this is kind of the various kinds of evaluations that we did. And this is what we saw, which is that we saw that in general, the ACT plus light worked best. We saw active changes in depression, in sleepiness, total sleep time, stress, in academic performance, and in concentration in each of these. So the stars represent difference from the baseline, and then in the stress and in the depression, the ACT alone was actually more effective than the lighting condition and the exercise. Um, and we see medium and um, uh, well, for at least for total sleep time and stress and concentration and depression, we see medium effect sizes for sleepiness and achievement. We see small effect sizes. So again, it worked pretty well. So we definitely see kind of this change. And one of the interesting things, and I should point out, is that basically when you take a look at the parameters, you have fairly modest changes. So for example, if you're looking at in the ACT plus light, you see around there's a 15-minute change in total sleep time when you compare the beginning to the end of the semester. So sleep got better, but not a huge amount better. But when you compare it to baseline, it got more than 20 minutes worse over the course of the semester. And that's true for all these parameters. So over the course of the semester, basically, the students got more stressed, more depressed, they got less sleep, their concentration was worse. They were doing worse in terms of academic performance. So basically, things got worse over the course of the semester. And these interventions either improved it a little or at least kind of retarded the decrement in all of these different kinds of outcome measures. And in general, what we see is that exercise was not quite as effective as light, um, which was about as effective as mindfulness, but mindfulness light was better. And again, when you look at this compared to control, you're increasing sleep by around 40 minutes per night. I should mention that when we looked at the exercise, we constantly changed the exercise. The exercise did not work. Basically, the idea was to get them into light, but something which I realized when I visited Taiwan is that it is unbelievably hot there, even at 8 o'clock in the morning. And two is that the young women, the young adolescent women that we were dealing with, there's a cultural push to have very light colored skin. So they actively avoid getting light exposure. So I don't know if doing another form of light exposure could be better in them, or if a different exercise intervention would be better. But this kind of exercise intervention did not work. And even when we moved to the volleyball, which is at least more interesting for them than the running, still many of them basically hid out in the shade as much as possible. So I don't think the exercise intervention was a very effective intervention in terms of getting to what we wanted it to do. Um, Even in the shade, they're getting more light than they would get inside. They're getting, between 5 and 10,000 lux of light. So it's still considerably more light than they would get inside, but it was not the amount that we were hoping for. Um, so that was kind of our first set of experiments. We then repeated the experiments and slightly changed things around. So this was a separate set of 12-week experiments. This was done in a different group of four classes, 120 students. Again, we had a control condition. We had a slightly different mindfulness condition that I'll show you. We had a morning light condition, which was similar to the other condition in the first experiment. And then we had enhanced lighting, which was all-day smart lighting, which I'll show you. And so again, here the idea is that the mindfulness was going to reduce pre-sleep anxiety. The morning light was to increase circadian amplitude. And then the enhanced lighting, which is actually lower light in the afternoon, is also meant to kind of highlight an increased in circadian amplitude. So in the control condition, we had very similar kind of outputs where we've got around 700 lux, around 1,000 lux near the windows, 500 away. So again, very uneven kind of lighting throughout the room. In the afternoon, it was a little lower, but again, uneven lighting, which is fairly typical in a kind of standard classroom with having fluorescent lighting. This is our mindfulness sleep intervention. Again, it's slightly different from the ACT one, more focused on the mindfulness parts of things, and a little more on the sleep. And so we did this. And this was kind of being kind of aware of the moment type of exercises, teaching them. And again, with the idea is that if you do this, you can kind of give them better control, and so that it's easier for them to kind of de-stress at the end of the night or at the beginning of the night when they're trying to fall asleep. Kind of the idea would be to enable them to more rapidly fall asleep. And so that's kind of what we were doing with the mindfulness here. And again, this was group taught in class, and so all the students were getting this in this classroom setting. Um, so the experimental setting with the morning light, again, we have the same kind of AIoT feedback. In this case, we actually used a slightly bluer LED instead of the slightly yellower one. Again, we had 1500 lux, and this time we just pegged it 1500 lux the whole time, since we found in the first experiment that having 1500 lux was acceptable to the students, so we didn't have to ramp it up over the course of the 12-week intervention. In the afternoon, they were getting standard fluorescent lighting in the morning light group. And then in the enhanced lighting, they were getting progressively less light in the afternoon with yellower light, so less blue light. And we kind of progressed that between 1 o'clock and 4 o'clock in the afternoon. And so those are kind of the two kinds of lighting interventions that we saw here. We had slightly different evaluations that we did in this group. Again, we did sleepiness in CASQ. We looked at emotion management. We looked at anxiety levels, critical thinking, and again did actigraphy for a week during pre and post intervention in order to take a look at the sleep. And so here you see a very similar kind of pattern that we saw in the first set of experiments, which is basically that things get worse for them over the course of the semester. So their anxiety gets worse, emotion management, critical thinking, sleep, and daytime sleepiness all get worse over the course of the semester. When you take a look at the impacts, sleep time, for example, really didn't change in these groups. So again, you have this condition where they are instead of improving sleep, it's just actually preventing sleep from getting worse. And so this might be a little worse than the last one, but it's still not bad. Still getting around 20 or so minutes extra sleep per night in these individuals. And again, most of that is not coming from that increase in sleep is not coming from an increased sleep duration in the sense that they're not going to sleep earlier or getting out of bed later. Is that once they're getting into bed, they're having more rapid shift in sleep onset time. And so they're able to fall asleep more rapidly. Again, we're seeing in the mindfulness condition, and you're seeing a more robust change in anxiety and emotional management, and you're seeing a slightly better, but not statistically better, effect in enhanced lighting versus just the morning lighting. But frankly, from a statistical standpoint, that they're pretty much the same. Again, anxiety, emotion management, and total sleep time all have medium effect sizes, small effect sizes with change in sleepiness and critical thinking, which is very similar to the previous experiment. So, summary. In all of the conditions, basically, again, things got worse over the course of the semester, but as compared to the control, the interventions are increasing sleep by 15 to 20 minutes per night. The mindfulness was definitely most effective on emotion management and anxiety. So that's kind of what you'd expect if you were comparing this to light. The light really didn't do very much on that, did a little, but not as much as actually active training in mindfulness. So, some take-home thoughts. First, sequence of light flashes during sleep can robustly and passively adjust circadian timing. So I've shown you this in combination with behavioral therapy in adolescence and how we can change sleep in adolescence. This can also be used in a variety of other circumstances where you want to change the circadian clock, the timing of the circadian clock. And I'm happy to discuss that with you. And there's lots of ways to optimize these kinds of light flashes. We've been working on it for about a dozen years or so. Importantly, that the light flashes alone really don't work to improve sleep in adolescence without coupling it to a behavioral therapy. And the behavioral therapy is nice, it gets you an extra 10, 15 minutes of sleep. But when you're coupling it with the light therapy, you're enabling a greater amount of sleep by moving this alertness window to an earlier time so that you can actually get more sleep. And again, in the shorter experiment, which was a month long, we got 45 minutes of extra sleep per night. And we're now taking a look to see if we can do this over the course of a semester. We're also looking at melatonins, and we're looking at academic performance and a lot of things like that. Secondly, we've got mindfulness therapies can really help and this is both ACT and mindfulness can reduce pre-sleep anxiety in adolescents, which can then lead to increasing sleep duration. So in that kind of population where this is a problem, and again, we don't see this as a big problem in the population that we've studied in the US, but this was a very large problem in the population that we studied in Taiwan. Then this was a very effective strategy to kind of reduce that anxiety and that teaching this in a classroom setting was a very effective manner of doing this. Using an AIoT classroom controlled lighting can improve sleep and academic performance. The nice part about this is that it is a totally passive thing, so you can just set it up and leave it be and then go away. We tested a few different varieties of this. I think that there's a lot more that can be tested in this. I think some good modeling has to occur first before we go into more kind of fancier designs. But I do think that there can be slightly more thoughtful designs with this. But the idea is that you can use these sensor arrays that have automatic feedback to lighting in the classroom, and you can kind of manipulate the light. And given the LEDs that are out there now, you have a near infinite space of possibilities of changing this. And of course, treating the root cause of the problem rather than the symptom is crucial. If had we done like we originally planned and give the light flashes to the adolescents in Taiwan, it would have been totally useless because again, that would have gotten them sleepy earlier, but they weren't going to sleep any earlier. Even if we had tried to convince them to go to sleep earlier, we've already spoken to them. We've spoken to the parents. We've done questionnaires. When we talk to the parents, um, and we say, well, according to the questionnaires, your kid says they're falling asleep 2 to 3 times per week in class, and in Taiwan, they're like, that's a good thing. That means they're studying hard. And as a sleep researcher, I'm kind of horrified by this, but then we get into it and we start talking about it. And they're like, well, show me the data that says actually getting a half hour more sleep is better than a half hour more of studying. And I'd say, the data aren't super convincing that that's actually true because of the variability in these kinds of variables. Now, do I believe it's true? Absolutely. But are the data there to really convince somebody? Not so much. So those are some take-home thoughts. Some acknowledgments. I've had tremendous support here at the VA from Jerry Savage at Stanford with Craig Heller and Bud Ruby at NCKU, Yating and Jean Ching, who is it's Yating's husband is Jean Ching, and he is the engineer who actually developed the entire AIoT lighting system. And then lots of funders and the many wonderful technicians and students and the postdocs who I've mentioned who have actually done the actual work. And with that, I will take questions. Thank you.
Thank you very much, Dr. Zeitzer, for that wonderful overview of your current work. We are open for questions. It looks like Dr. Salatin has his hand raised already.
All right, Jared, how can I help you?
Jamie, that was great. Thank you so very much. The what you said at the very end about they wouldn't have helped them because they wouldn't have gone to bed earlier. I'm reminded of that data from Andrew Fagini down at UCLA where he showed that the there was this paradox correlation of like if you studied more, you did worse at school. And then students got all excited about that until he revealed that the reason that that correlation exists is because they were sleeping less as a function of studying more. And I was just wondering whether you had like, do we see that same mediation in those kids in Taiwan? And can you narrow the angle a little bit or buffer the mediation a little bit?
Yeah, so we took a look at that and we didn't see that. We saw that the amount of sleep that they were getting was definitely related to when we did a path analysis, and the amount of sleep that they're getting were related to the emotional outcomes, but not to the academic outcomes. So again, I'm not saying that it's not because again, the N is going to be insufficient really to truly answer that question in this particular case. Um, but I think in terms of a public health. Oh, so when we did this in the US, by the way, when we talked to the parents and we actually separated out to parents, first and second gen parents of Asian descent in the US, where we have a lot of that in the Bay Area. they had very different opinions about sleep. They were horrified about sleep here. But again, we were talking to them in Taiwan. They're like, no, this is great. This is awesome. Um, and and I'm like, no, it means that like not only are they not getting the benefits of sleep, they're falling asleep in class. But so much of actually the education doesn't occur in class. It's happening outside of class. So it's really on their own. Um, so, in terms of public health, I do think we need to really understand, how much like basically where are there diminishing returns in terms of sleep and studying. Like if we say like, and I do think it's going to be like a sigmoidal curve. Like, all right, if you got 5 hours of sleep versus 8 hours of sleep, yeah, you know what? 8 hours is better. It's going to be a lot better, right? But how about 8 hours versus 7 hours? Like, how much better is eight than seven? How much better is like, where is that kind of that drop off in the curve? Because then I think you could really give good advice to say, you know what? If you get 7 hours, you're at 90%. If you got 6 hours, you're at 70%. So you really want to go for that 7 hours. Like if that, whatever that is, I think that would be very useful. Because right now, I mean, maybe there's data I'm not aware of, but right now I'm just hand waving with this stuff, like, oh yeah, 7 hours, 8 hours, yeah, it's all good. But it's so I think that's probably, and then with studying, it's a similar kind of thing. Like when do you basically like, yeah, I just spent the last hour studying and I got like 0.5% better, which I think we've all experienced at different points. Um, and then you close the textbook and then you're like, oh, forget it, I'm done. I'm not doing this anymore. They study much later, and I don't think that they've got the magic efficiency for this. So anyway, I think this is an incredibly important question, and I hope you answer it and let me know so I don't have to do it.
Fun stuff.
Yeah,
I think Mary
Mary.
probably has.
Hi. Uh, Really fun, interesting, fascinating data you shared with us today. I have a few questions.
I knew you would. I was looking
You
forward
knew
to it.
I would. First, we tried to do classroom enhanced lighting at one point, and we would set it and forget it.
Yep.
But then the teachers hated it and would turn
Yep.
our lights off.
Yep.
So how did your Taiwanese teachers react to the light?
They're more deferential.
Okay.
So, but I agree. I think that's a problem so in different case scenarios, and I apologize. I forget the person I was talking to was actually doing this in an old age home and showed that you had to kind of ramp it up to be more acceptable. So I don't know if ramping it up helps, but I do know that what you've described there with the enhanced lighting in classrooms um, is is also problematic, for example, in hospitals, doing enhanced lighting in hospital settings where the nurses hate it and they just turn it off and don't use it.
Right.
So I agree that it's problematic. So I don't think that we had a magic formula for this. I do think that the teachers were more deferential in saying, okay, we're doing this, and why are we doing it? Because we're doing it and we're told to do it. So we're just
Right.
doing it. Um,
Yeah, a little
and
more cultural impact there.
absolutely.
Okay, next. So one thing that I missed in your presentation was seeing more of individual differences. And so I wondered, were there some participants who really, did great with your interventions and others who just sort of didn't respond at all? Or was there kind of a
100%. Yep, absolutely. And it's something that we're doing now is you're trying to figure out why.
why? Yeah.
So that's what we're trying to explore now. We don't have a great data set for that. It's okay. Um, and because I'm so basically I'm not so we've looked at stuff like, well, so first of all, we get a lot of variability in response to the light. So is that some of it? Hopefully we'll see that now that we're collecting melatonins. We'll hopefully see like, is it that, oh, the people who are actually phase shifting more have an easier time? Is that it? Um, um, is it a personality thing? Like
Mhm.
how well they do? So again, I think there are super important questions in there because it is not a universal, like, oh, everyone, like, everyone shifted, and got 45 minutes of extra sleep, and it was 45 minutes plus or minus 3. No, I mean, it was very variable.
Yeah.
And And we definitely had some people who were getting more than an hour of sleep. I do think in this population, an hour is pretty much all that we can get from them.
Yeah.
It would be really hard pressed to push them for more than an hour. We
Hour.
also, there's also the issue that we're trying to get at, but I don't think we're going to do a very good job at it, frankly, of how much of this is driven by the students and how much is it driven by their parents. Because a lot of times the students say, yeah, yeah, I want to do this. But what they mean is, yeah, yeah, my parents are hawking me about this and I don't want to deal with it. And if I sign up for this study, they're not going to bother me anymore.
Right.
Um, so as opposed to a student who is truly motivated to go to sleep earlier.
Yeah.
Um, and so it's a great question, and I don't think we're going to do a very good job answering it. We're trying to, but I don't think I'm asking the right questions about that at this point. Um,
Well, I mean, there's so much. So, I mean, we think, oh, homeostatic, circadian, but there's so much else going on, and you've
Absolutely.
addressed a fair amount of it. I wondered what your initial plots of the initial work showed a significant amount of social jet lag still occurring, and I wonder if you've looked at, those kids who had the biggest change in social or who still had a significant amount of social jet lag were also the ones more resistant to the lighting exposure.
Right. So I should say those are fake plots,
Oh, okay.
but it's a very good point, and I have not looked at that, but that's a good thing to take a look at. And I've not done that yet to see if that's who, I mean, maybe they're the worst at responding or the best at responding. Um, but that's a very good question, and that actually gets at some of the stuff that we need to do in the Taiwan data as well, which is to see, if the ones who are sleeping in longer on the weekends, uh, do they have a weaker circadian system that would be more benefited, would get more benefit from an increase in amplitude.
Right. Finally, sorry, I'm taking everyone's time here. Um, in the States, we also have a public health solution, if you will, in the school start time change
Yep.
effort. And I wondered, so years ago, I was invited to Korea to speak to, I think it was the Minister of Health and Education and a few other people, a small event. And their big concern was these after school intensive, like going back to school in
Yep.
the evenings. And I wonder, I know there's a huge cultural, as you already alluded to, um, expectation of that. But I wonder if there might not be an opportunity for public health interventions around that. Would you call it cram
Yeah.
education?
Oh, absolutely. I mean, this is something which is definitely, um, I 100% agree. It's totally outside of my purview. But I absolutely think it has to get done. But it would be a major cultural shift
Right.
to have them give up the cram schools. It is present throughout Southeast Asia and East Asia. You see it in India,
Yeah.
um, basically in the it, again, it's private school, so it's among the middle and upper classes. But this is an expectation. This is not optional.
Right.
Where
Even if they could minimize the number of hours, something.
I
But
agree. There's
and it
absolutely
costs families a ton of money.
yes, but
It's it's huge
and then
expense.
yeah, so there's a tremendous push for that. Again, I think it gets into this: can we show that sleep is better than cram school or studying or homework
Right.
and stuff like that? Basically, where is and this gets at, I think, Jared's question, where is that balance between these things? So even if you spend, no time on social media and gamings, which again, they really don't spend a lot of time on it there, is spending time on sleep, this is really a substitution algorithm. If you spend more time on sleep, do you end up doing better? Or the same, but maybe you end up doing the same academically, but the depression rates aren't through the roof because they are through the roof in this group. I mean, the amount of depression. Again, we did scales, so I don't want to say that they are depressed, but basically consistent with extremely high rates of depression in this group. Um, and my guess is that if we had done clinical evaluations, that good two-thirds, if not three-quarters of them would have been severely clinically depressed.
Yeah.
But it's again, it's a cultural issue, and I leave that up to people, other people. I don't think seeing white guy from the U.S. Telling them to get rid of cram school is going to help out too much.
Oh, yeah.
But I do think so. I absolutely agree. But I think getting that data to show, because I do think that if you show that, yeah, you get more sleep, if you get an hour more sleep and you have an hour less cram school and you do better academically, I think they'd be totally into that.
Maybe. I
Maybe,
can
yes.
only hope. Well, Jamie, I mean, thank you again for giving us this wonderful talk. And if you ever think of something where you might want East Coast collaborators
Absolutely.
to join your team, let us know, and then you could visit and then be closer to your child's
There
school.
you go. Excellent. Thank you. I mean, I gotta say, whenever we've talked about doing kind of lighting interventions in school, I'm like, it's useless in California. Like I grew up on the East Coast, like, and when I came out here, I was like, what is this? This is not a school, because it's not a building. It's a bunch of buildings. Like when you leave your classroom, you're outside.
Yeah.
It was the weirdest thing
I
going.
remember, yeah, Gun High School was like that.
Yeah,
All
it's
this.
all outside. So it's like classroom lighting intervention not going to do anything because they're getting a lot of light, and it's always nice out here. But you go to Providence, and then you got snow, you got rain, you got cold, you got
Come
big brick
on, it's not
buildings.
that bad.
Oh, I miss it. But I'm saying is that you have weather,
You're right.
and so you have an opportunity to actually change the indoor lighting, because they're not outside all the time.
Right.
But alas.
Alas.
Well, thank you so much, Dr. Zeitzer. We are at 1:05 p.m. Eastern time, so 10:05 your time. I know, Dr. Coles, you had your hand up for a little
Yep.
bit. Is it okay if we take one more question, or are you
I'm happy to if you guys
okay?
have it.
Oh, thank you. You didn't have to. I'm playing around and kind of being the devil's advocate to think of other things. And in my head, I'm saying that nature or whatever humans were created, we're pretty good at doing things unless we mess with them. And we've been trying so hard to get these adolescents to go to bed earlier. What if we don't? What if they're doing the right thing and we should let them do it? What happens when you take that bottle and then where do you end up? What does do you need an intervention, or what does it be? For me, it ends up with schools aren't structured the way kids and adolescents learn, like putting elementary school kids sitting at a desk all day,
Yeah.
So I just was wondering what thoughts you had about that. Like they have this natural shift later and then they shift back. And I always wonder why do we have that shift and what's the function of it?
Right.
So
Oh no,
I don't know if you have any thoughts. It's a big one.
yeah, no, absolutely. I think the stuff that Mary's done. And at first I thought, oh, it's circadian, but I got to say, I don't think so. I mean, the stuff that come out of Brown has really said, well, it's probably that the homeostat's changing, and that basically is that the accumulation of sleep is slower, so they're just not getting tired until later. Now there's still that last question of, well, then why is it from, say, why are they sleeping from, say, or why would they prefer to sleep
Right.
from, say, 2 to 10
Right.
and not 4 to noon,
Right.
or 1 to 9? I mean, but I do think that that shift later is a homeostatic thing. And Mary, we've got some, which I'll share with you at some point. We've got some really nice modeling data to support that.
Oh, cool.
And again, it's been a big puzzle. Now, again, should we do this? I mean, again, from a strictly biological circadian perspective, absolutely. You should just have high school start later.
Yep.
And they should start at 10 o'clock. Now, again, like my oldest, who's up in Maine right now, he still gets up at 6 o'clock in the morning.
Wow.
But I keep on telling him he's weird. I mean, for many reasons, but
Yeah.
like 6 o'clock in the morning is not normal for a college student, let alone a high school student.
Right.
But that's his preferred time. And so, but on average, would it help people starting later? Absolutely. But it's an entire structural change to things
Oh
like,
yeah. Yeah.
when do, when do the, um, when do the teachers get there? Like in this area, it's too expensive to live in the area. So teachers like getting there early so they can miss the commute traffic.
Yeah.
Um,
And I don't think
yeah.
it's realistic, but it just helps me think about what purpose is it serving or why is it happening.
No,
And
absolutely.
for what it's worth, I'm in upstate New York and my son's at school in Boulder. He went the furthest of anyone in his class. So
Yes.
I can
Well,
relate.
and look, and this gets to Mary's point about, changing the school start time. This doesn't work in opposition to that.
Right.
It can work in conjunction. So you start schools later and still not enough time for many of these students. I mean, a lot of these students are still going to sleep, at 1 o'clock in the morning.
Yep.
If you go to sleep at 1 o'clock in the morning, your school starts at 9, then maybe you can get 8 hours.
Yeah, we
And if
have
you're going to
over
sleep at
50%
2,
of undergrads go to bed after 1 a.m. It's like 62%, 60%.
yeah. Well, this is what I always, whenever I talk to high school students, I say, just wait until college and make sure you become a liberal arts major, and then you can sleep until 1 o'clock in the afternoon, and you're all good. But not a science major. We got to get up too early.
Oh shoot, I did both. Thank you. I really enjoyed the talk.
All right, thank you.
Thank you, everyone. And thank you, Dr. Zeitzer, again. Our next Thomas F. Ender seminar will be October 21st, I believe, with Dr. Vernon Grant. Thank you all. Take care.
Thank you.
Thanks again, Jamie.
Bye.